Here is another example on networking. Find the shortest distance in the network below using Dijkstra's algorithm. As we did the other example above, we identify the origin of the source as 0p. So we start by identifying this as 0p, and now the rest becomes infinity, temporary, infinity, temporary, infinity, temporary, infinity, temporary, and also this one is infinity, temporary. After identifying all of them as I have done above, we identify the points where we can reach from the source directly. Here we have from point 1 we can reach point 2, point 3, and point 6 directly. So we start by saying now current is D1, and we can now reach D2, D3, and D4. We can reach D2, D3, and D4. So we find new D2. This one is just the minimum between D2 and the sum of D1 plus the weight of 1 and 2, weight of 1 and 2, which is just minimum between our D2 is infinity, this one is infinity, and D1 is 0 plus the weight is 7. So the minimum here becomes 7. The minimum becomes 7. The minimum between infinity and 7 is just 7. We also need to find new D3, which is the minimum between D3 and D1 plus C13. This is the minimum between, what is D3? D3 here is infinity. D1 plus the weight, D1 is 0 plus the weight here is 9. So it becomes 9, the minimum becomes 9. We go ahead and find new D6. We can reach D6, not D4, it is D6. We can reach D6 here. So new D6, this is minimum between D6 and D1 plus C16. So it is minimum between, what is our D6 is also infinity plus 0 plus our weight is 14. Our weight is 14, and this one gives us 14, the minimum to be 14. So in the 3, the smallest we identify as permanent, so this is 7p, this is 9t, and this is 14t. We come to our diagram or our network. We put there those figures. So our D2 becomes 7p. So this one becomes 7p. Our D3 becomes 90. This one is 9t. Our d4, d6 becomes 14t. So this one is now 14t. Is 14t. Now we have our current as d2. Again, current is at d2. From d2 we can reach d3 and d4. Can reach d3 and d4. So you can reach d3 and d4. Can reach d3 and d4. So we need to find new d3, which is the minimum between d3 and d2 plus the weight of c2, c3. This one is giving us minimum between, what's our d3? Go to d3 is now 9. D2 plus the weight, d2 is 7 plus the weight is 10. D2 is 7 and weight is 10, so it is 7 plus 10. The minimum here is 9. The minimum is 9. You go ahead and also find new d4, because you can also reach d4 from 2. New d4 is the minimum between d4 and d2 plus the weight c2, 4. That is the weight, which is the minimum between d4. When you go here, d4 is infinity, and d2 is 7 plus 15. 7 plus 15. So this is 7 plus 15. The minimum is 22, because 7 plus 15 is 22. So the minimum here is 22. Well, because there were only 2 points we can reach, we identify the smallest as permanent. So this is 9p, and now this is 22t. 22t. We present them on the diagram again. So our d3, our new d3 becomes 9p. So this one is now 9p, and the d4 is 22t. d4 is 22t. So this means that now our current is at d3, and from d3 we can reach d6 and d4. We can reach d6 and d4. So current is d3, can reach d4 and d6, can reach d4 and d6. So we need new d4, which is just the minimum between d4, d3 plus c3, c4, c3, 4. That is the weight. So this is the minimum. What is our d4? When you go there, our d4 is 22. Minimum between 22. D3 here is 9 plus weight, which is 11. 9 plus weight, which is 11. We get 20. We get 20. We also need new D6, new D6. So this is the minimum. Let me confirm something here. Well, it's a minimum between D6 and now D3 plus the weight, which is C36. So it is minimum between, what is our D6? Go there and find D6 was 14. D6 is 14 here. And now D3 here is 9, and the weight here is 2. Please note here that the weight is 2. So it is 9 plus 2. So the smallest here is 11. The smallest is 11 because I have 14. 9 plus 2 is 11. Smallest is 11. Now here the smallest was 20. Yes, 22 and 20. The smallest is 20. So we identify this as 20T because it's the largest, and now the smallest is 11P. So let me present here on the diagram or the network. D6 becomes 11P, and now D4 becomes 20T. This one becomes 20T. So from here, our current is now at D6. We can only reach D5. From D6 we can reach D5. So come here and say current is D6, can reach D5. So we need new D5, which is the minimum between D5, D6 plus C65, that is the weight. So this is the minimum between, what is our D5? We go to D5. D5 is infinity. D5 is infinity. D6 plus the weight. D6 is 11 plus the weight here is 9. So it becomes 11 plus 9, which is now still 20. It is 20. So because it is the only point, we identify it as 20P. So it becomes permanent. I come to the diagram here. I change this to 20P. I change it to 20P. It becomes our permanent. Again, it becomes our permanent. So our current is now at D5. From D5 you can only reach D4. From D5 you can reach D4. D5 we reach D4. So come here now, say again, current is D5. D5 can reach D4. Can reach D4. So we need new d4, which is the minimum between d4, d5 plus c4, 5. That is the weight. So which is the minimum between, what's our d5? d4, I mean, go to d4, it is 20. Minimum between 20. d5 plus the weight, go to d5. d5 is here, it is 20 plus the weight, which is 26. So 20 plus 6, this one gives us minimum to be 20. So here becomes 20p. This one becomes, let me write this, 20p becomes our permanent. So we can change here to 20p. When you look at those points, all of them has been identified as permanent. All of them has been identified as permanent. So we stop there. We stop there. Well, now the shortest distance, shortest distance equals to 20. The shortest distance is 20. We need also now the shortest path. We have 1 to 3, 3 to 4. 9 plus 11 gives us 20. So the shortest path is from 1 we go to 3, from 3 we go to 4. That is the shortest path. That is how we deal with the questions on networking using Dijkstra's algorithm. Thank you very much for watching. Make sure you subscribe, like, and give a comment down there.